Hey folks, welcome back. We're getting ready for exam 2. We're going to crush it, and this time we are looking at an impact and systems problem. So the physical system is that we have pool balls, 3 pool balls, and ball A impacts balls B and C from this V naught, which we're given to be 12 feet per second. The collisions ensue, and we are given that VC is 6.29 feet per second, and we are asked to find VA and VB. So let's get to it. In particle systems problems, it makes sense to start with the momentum and then use the impact equation if necessary. So let's start with momentum. Well, in order to do that, we need the components, right? So let's make a list. So V naught is 12 times the I direction is going to be the sine of 45. Let's see, we can actually just put these together, right? So let's do that. Let's say 12 times the sine of 45. And actually, I misspoke. That's the cosine of 45, but it doesn't actually matter. So let's see. Let's write this in vector notation. Let's see. This is 8.485. And it's the same in the J direction. Okay, and then VA, we don't know what VA is, but we do know that it's leaving in a direction. So let's see, the I direction is going to be the sine of 4.3. So let's see, the sine of 4.3 degrees is 0.075. and that'll be VA. Okay, and then we need the cosine of that. 4.3 degrees. Okay, and that's 0.997, so 0.997 times VA. Okay, those are our components. And VB, we don't know that one either. And in the I direction, that's going to be the sine of 37.4. So what is that? That is 0.607. 0.607 times VB. And likewise, we're going to need the cosine of 37.4. We'll need negative cosine. Let's see where we're at here. Cosine 37.4, okay, 0.794, and that's minus 0.794 VB, okay, and then VC is the, well, we know that that's 6.29, right? So 6.29, in the I direction, the 6.29 times cosine 30. So 6.29 cosine 30 is 5.447. Okay, then the sine of 30 is just half of it, right? So what is that? 3.145, right? 3.145. Right? That's 2. That doubles to 90. Okay, perfect. All right, so now that we have the components, now we just start with the conservation of momentum, right? And what is that? That is in a system, that is the sum of MI, VI 1, I guess, position 1, is going to be equal to the same thing, right? So writing that out, we would say MA V naught plus MB V naught B plus MC V naught C equals MA VA, and notice that V naught is just VA prior, right? It was coming in at V naught. So let's see. MA VA plus MB VB VB plus MC VC. Okay. All right. So balls B and C were not moving to begin with. So these go to 0. And this is the game of pool, so all the balls are the same size. So goes to 1, that goes to 1. They all do. Okay. So rewriting this just so we can see what's going on. V naught equals VA plus VB plus VC. Okay. All right. Well, we broke them into components, so now we can just go in the I direction and then go in the J direction, right? So let's see, in the I direction, let's see, I hat direction, I guess. I hat direction, what do we have? We have 8.485. Equals VA is 0.075 times VA plus VB is 0.607. VB plus 5.447. Okay, and I can reorganize this and subtract 5.447 from here. And what do I get? I get 0.075 VA plus 0.607 VB equals, and let's see, 8.485 minus 5.447 gives me 3.038. 3.038. Okay, that is equation 1. All right. Let's see, equation 2. Right, which we need because we have 2 unknowns. All right, so that's just the same thing in the J direction. So 8.485 equals 0.997 times VA minus 0.794 VB plus 3.145. And just like we did in the I direction, I'll just subtract 3.145 from both sides to get an equation that looks like the equation 1. So 0.997 times VA minus 0.794 times VB equals, let's see, 8.485 minus 3.145 equals 5.34. 5.34. Okay, 2. All right, and I'm going to use a matrix method here to solve this, and just row reduce it because that's when I start decomposing lots of things, then that's how I do it. So let's see. Let's do it in real time. I did it a few minutes ago, but let's see. I bet it doesn't take that long. Let's see. Gotta tell the calculator what I'm doing, and then I'll punch in numbers. So that usually takes the longest. Just saying, hey, we're going to row reduce and put it into echelon form. Okay, all right. So we got that done. Now I need the coefficients: 0.075, 0.607, not 067. That will mess things up. 607. Okay, then 3.038, then 0.997, a negative 0.794, and finally 5.34. And it looks like I did it right. Okay, cool. So, let's see. Insert. Insert here, right? That's what I did. This was the math. I used a row reduced echelon form. My calculator. And what did that give me? That gave me that VA is equal to 8.505 feet per second, and VB is equal to 3.954 feet per second. There we go. So we got lucky there. All right. Well, there you have it. I hope that was helpful, and I will see you in the next video.